Underground mining is essential but highly hazardous, producing toxic waste, environmental pollution, and long-term health risks. Abandoned mines worsen these impacts. Rising demands for minerals like copper, lithium, and nickel increases operational pressure and safety risks, including human error, environmental effects, equipment failures, and general operational issues. This video was made to identify major underground mining risks and proposes suitable control measures for safer and more sustainable operations. Hazard identification is essential in underground mining to recognize dangers early and protect workers, equipment, and the environment. The main hazards fall into four categories. Firstly, human factors. Underground workers face significant health and safety risks, including heat stress and respiratory illnesses. Accidents are also more likely in confined, hazardous environments. Human error is another major contributor to risk. Fatigue, poor communication, and inadequate training can lead to unsafe actions. Additionally, the psychological pressures of underground work, such as isolation and long shifts, can reduce focus, judgment, and overall mental well being. Next, environmental factors play a major role. Poor air quality and ventilation can expose workers to dust, low oxygen levels, and toxic gases such as methane and carbon monoxide. Water seepage and groundwater inflow can cause equipment failure, electrocution, and potentially severe flooding. Geological instability is also a serious threat as roof collapses, rock bursts, and ground failures can cause deadly incidents. Third, we assess machines and system factor. Mechanical failures in equipment such as drilling machines, conveyors, or ventilation systems can occur due to wear and tear or inadequate maintenance, leading to injuries and operational disruption. In increasingly automated mines, digital systems introduce new risks, including cybersecurity threats and downtime from software defects. High voltage electrical components and pressurized hydraulics can also result in electrocution or mechanical injuries if not properly managed. Finally, general factors influence overall risk levels. Geopolitical or economic instability can interrupt safety, investment, and disrupt mining supply chains. Limited financial resources may reduce the implementation of essential safety measures, increasing exposure to hazards. Regulatory gaps and weak enforcement of workplace safety standards further elevate existing risks.
Next, we have risk assessment. This assessment will protect workers' health and safety. It also produce accident, injuries, and illness. It also improve productivity and morale. Other than that, it will ensure legal compliance with all regulation. Safeguards the community by preventing environmental and public health risks. This risk assessment include likelihood in a range of 1 to 5 with inconceivable, remote, conceivable, possible, and most likely. With severity from range 1 to 5, negligible, minor, serious, fatal, and catastrophic. These two likelihood and severity will multiply and resulting risk level from 1 to 4 that is low, 5 to 12 that is medium, and 15 to 25 is high risk level. Furthermore, we also include risk matrix tables. This table we explain about hazard, likelihood, severity, risk rating, and risk level. First, we have human error. There is likelihood of 4, severity of 4 as well, and risk rating of 16. resulting risk level high. Next, we have environmental weather, with likelihood of 2, severity of 4, and risk rating 8, resulting risk level medium. Next, other than that, we also have machinery failure. That's most like with the likelihood of 4, severity of 4, and multiply it resulting to risk rating 16, that meaning that the risk level is high. Lastly, we have air ventilation with a likelihood of 4, severity 3, resulting risk rating 12, meaning that the risk level for air ventilation is medium. After all that, we have hazard control measure. That is by following the hierarchy of control with the elimination, substitution, engineering control, administrative control, and PPE. As for our first hazard, that is human error, social and psychological pressure. As for the elimination, we can the building and the maintaining social lesson to operate, SLO, meaning that if the workers does not have the lesson to operate, they cannot work. Next, we have the substitution, that is adopt diversity and inclusivity. Furthermore, we have engineering control, that is utilize machinization, digitization, and automation as our three mean for our tools and machinery. Next, we have the administrative control, that is build a solid relationship with their community and contribute to their life, meaning that we have to care and help the other workers to do their job safely. Lastly, we have PPE, that's implement annual medication examinations to routinely screen workers, meaning that we will know their medical and also they'll yearly check on them to make sure they are all healthy and ready to go. Moreover, we have environmental factor for the hazard control measure. First, for the elimination, we have integrate adaptation strategies into existing mine operation. Next, for the substitution, we have developed renewable energy as alternative, meaning that we can use solar energy and other. Next, we have the engineering control, that is enhance energy efficiency and secure water resources to deal with the environment risk. There's like flood or like natural disaster or something, mostly like flood. Second last is an administrative control, that is critical assessment and planning of resource policy. That we have to carefully plan out for it to work. Lastly, we have PPE, that is the workers will wear waterproof outwear, thermal layers, and insulated headgear, so that if there are sudden weather like rain heavily and might be flood, for the worker that is working underground, it might be dangerous for them. And with the PPE, they will stay safe. Hazard control measures related to machinery failure in mining operations, focusing on electric and hydraulic systems. As shown on the slide, machinery failure can lead to serious environmental consequences. When systems break down, mining, tailing, and chemical byproducts may leak, polluting the surrounding soil, water, and air. To control this hazard, regular maintenance, proper system checks, and emergency shutdown protocols are essential. Use safer hydraulic fluids and training workers to spot signs of failure can also reduce risk. By implementing these measures, we can minimize environmental damage and improve safety in mining operations. Hazard control measures focus on air quality and ventilation in mining operations. Mining environments pose serious risk. Tunnel collapses, landslides, equipment accidents, and flooding can lead to severe injuries or even death. But one hazard that often overlooked is poor air quality. Without proper ventilation, toxic gases and dust can accumulate underground, threatening workers' health. That's why it's crucial to install effective ventilation systems, monitor air quality regularly, and ensure workers wear protective gear like masks and high visibility vests. By controlling air quality, we not only protect life but also improve overall safety in mining operations. For conclusions, first of all, we have sustainability and economic vitality. Mining remains crucial for economic growth, but ensuring sustainability requires stricter enforcement of environmental regulations. Safety and proactive is an effective hazard management were essential for ensuring safety and sustainability in underground mining. After that, we have a risk management strategy, where risks like rockfalls, gas emissions, equipment accidents, and confined space demand systematic monitoring and proactive management. After that, we have accidents reductions. Mining companies can significantly reduce accidents and occupational illness by implementing engineering controls, eliminations, and PPE, which stands for personal protective equipment. And lastly, we have benefits of a safety culture. These safety practices protect workers and enhance productivity and strengthen community trust. Recommendation for improving workplace safety. To begin with, we have enhancing health monitorings. Miners should conduct annual medical examination where they get routinely screened for mycobacterial disease such as tuberculosis, which has been noted as a high health risk. Secondly, we have mitigate exposure risk. Safety intervention and stringent regulations are required in the industry, which remains one of the most dangerous industries to work in, especially in underground setting involving drilling, blasting, and other labor-intensive tasks under the weight of rockaballs. Thirdly, we have addressed community health. Recognize that health risks of communities have a direct bearing on the organizations due to seamless disease transmission. This also entails managing the increased burden of community health provision, which arises when surrounding communities are unwell. Lastly, we have strengthened workforce stability and skills. Companies should spend more upskilling and reskilling workers to deal with the exodus of experienced talent and the difficulties in attracting younger employees. Adopting diversity and inclusivity is also suggested as a strategy to deal with the risk of rapidly aging workforce globally.